Guten Tag, meine Lieben. Welcome to another tutorial. Actually, this is the first tutorial of a new series about working with JIT.GEN, but not working on video or image content, but specifically with three-dimensional shape. So using the JIT.GL mesh object with the JIT.GEN object. So using these two objects in combinations in order to create some interesting three-dimensional or two-dimensional shapes. Okay, so let's see what we have here. We have the GGL Gridshape object. And the reason we have this object here is because with this object, if you set the attribute Matrixoutput, it will output the matrix containing the whole shape from the left output. So if we put JIT.P window here, we can see that the object is actually putting out a JIT matrix. So let's see what this matrix is actually made of. Let's use the JIT matrix info object. So this is, we can say that this is a 12 planes matrix of type float 32, and the dimensions are 20 by 20 because by default the dimensions of a grid shape are 20 by 20. So let's actually break down this matrix and see what is in every plane. In order to do this, I've prepared this image here. So there is an explanation that you can find in the Max reference somewhere, I don't remember where, I think in the Obthread page, that explains you what is inside every one of those planes. So let's see. The first three planes are the coordinates of the vertex or the vertex. Then we have the planes 3 and 4 that are the coordinates of the texture. 5, 6, and 7 are the coordinates of the normals for every vertex. 8, 9, 10, and 11 are the color components, and the 12th plane is the edge flag, which we don't care at all for now. So this JIT.P window here is visualizing the first 4 planes, but I actually want to visualize the different components in a different P window for every series of components. So let's use a JIT unpack object to realize this task. Let's have 4 output, and then let's make some jumps, which means that we're going to take just a fixed amount of planes for every output. So from the first output I want the first 3 planes, which are the vertex coordinates. From the second output I want the texture coordinates. From the third output I want the normal coordinates, and from the fourth output I want the color components. And let's set some offsets. So the first offset is 0 because these are the first 3 planes. The second offset must be 3 because we have to jump the first 3 planes. And so on, we have to jump the first 5 and then the first 8 planes. Whoops, jumps. I got carried away. So let's connect this here. And then let's connect these to some JIT.P window. So now we have the vertices here of the shape. We have the texture coordinates, we have the normals components, and we have the colors here. So let's make a bit of tags. We have the x, y, z vertex coordinates, and this is a 3 planes matrix. Yeah. These are the S and T texture coordinates, and this is a 2 planes matrix. These are the, let's actually use this. These are the X, Y normal coordinates, and this is a 3 planes matrix. And these are the R, G, P, and alpha color components, and this is a 4 planes matrix. Okay. let's see actually what is inside those matrices here. Here we are actually visualizing exactly the components of the shape. So by now the shape is a sphere. If we make a cube, it will look different. If we make a torus, it will look different again. And cylinder, it will look always different. Because these are actually really the vertices of the shape. So if we create a JIT.GEN mesh and give it the matrix on the first inlet, which says vertex array, these are exactly the vertices of the shape. So the JIT.GEN mesh will recreate this shape. Let's create a JIT.GEN camera also and put it a bit farther from the object. So position 005. Okay, let's make it a bit closer. Yeah. So now we have our mesh is visualizing the shape. So these are really the components of the shape outputted from the grid shape. If we say cube, it will output a cube, torus will be a torus, and cylinder will be a cylinder. Let's create an handle to better visualize these shapes. So handle gen01. And so you can see that this is a cylinder. We don't have the light for now. We will see it later. Okay. So let's come back to the sphere. So in this matrix here, in this GTP window here, we can see that the red color are the x position of the vertices of the sphere. The green color is the y position of the vertices, and the blue color is the zeta component of the vertices of the sphere. So let's take a look now at the texture coordinates. So the texture coordinates is a two-dimensional matrix where the x dimension goes from 0 to 1 and the y dimension goes from 0 to 1 on the vertical axis. We are visualizing it like green and this kind of purple because automatically the JIT.P window fills the first plane and the third plane with the red component and the second plane and the fourth plane with the second component of the input two-dimensional matrix. So the red component, so the x component of the texture coordinates goes to fill the alpha channel and the green channel, and the y component goes to fill the red component and the blue component. So it's a bit like interleaves this two-dimensional matrix into filling a four-dimensional matrix. Then we have the normal coordinates. Let's make a pause here and see what actually is a normal. So let's make a painting here. Let's take a funny color. So a normal is a vector that goes perpendicular to every polygon of a surface. You know that a three-dimensional object shape in computer graphics is made of triangles. So for example, a sphere will be made by an approximation of triangles to make it spherical. This is my best attempt to draw a sphere made of triangles, so just a portion of a sphere, and so on. It's not really spherical, but you got the idea. So a normal is a component that from every vertex goes perpendicular to the surface. So something like this, where this angle here, it's 90 degrees. Oh, that's really hard. Okay, so this is 90 degrees. So every normal has 90 degree with its specific triangle, because every triangle here lies on just one plane. So the cool thing about triangles is that when you make a triangle, it just lies on one plane. So this is one plane. So every normal will be perpendicular to this plane where these triangles lies, and every vertex has its own normal. So this is what a normal is a vector that goes perpendicular to the specific vertex, actually, you need two edges to calculate the normals. So an edge is this part of the polygon. And this is, or if you're talking about this normal here, then will be these two edges. So when you have two edges, you can calculate a normal component. And the normal component is important because it is used in light calculations. Another important thing that there is to know about normals is that normals just represent a direction. Actually, they are often normalized, which means that the magnitude of the vector normals is 1. It's always 1. So the normals don't have actually a magnitude. It's not important their magnitude, just their direction is important. So for the JIT.GEN mesh to calculate the light, it really needs the normal components. In fact, if we try to give this mesh the lighting enable attribute, you will see that nothing changes because it doesn't have the normals to calculate the light. If we take the normals components from the object and connect it to the normal array, nothing happens here because the world is not playing. But yeah, you see that now the object. So let's make it correct to see that wasn't working before. Let's delete this. Let's recreate the object. And see that if we doesn't give it normals, it doesn't work. But if we give it the normal, no, this is the color. Sorry. So if we give it the normal into the normal array input, then we get the object with the correct, almost correct lighting. So every normal is applied to a specific vertex. So this is what normals are. The texture coordinates are also important for the JIT.GEN mesh, because without texture coordinates, the texture that we apply is a bit, it won't be applied actually. So let's create a JIT.GEN texture. And let's try. Let's name it text0. So let's create a JIT matrix. And let's take a video, for example, here. Connected to the, actually, let's connect directly to the JIT.GEN texture and see what we get if we apply the texture to the mesh. So, okay, we see that the texture is somehow applied, but it's not playing correctly. So, in order to make it play correctly, we have to assign the texture coordinates to the mesh. Okay. And now you see that the texture is applied correctly. You will see this better if this object would have a color of white. Yeah. Now you see that the texture is applied correctly. If we don't give it texture coordinates, the texture is not applied correctly. Zack. Texture is now correctly applied. And let's go 1 second back to the normals. One thing that you may have noticed is that the vertex coordinates of the sphere and the normal coordinates of the sphere are actually the same. So let's look at the cube. They are different in the cube case, and also the texture coordinates are different in the cube case. But for the torus, also different. For the cylinder, are almost quite different. But for the sphere, they are the same. So if we draw a sphere, maybe there is a tool to create circles, yeah. If we draw a sphere, the position of each vertex on this sphere, I will just draw the silhouette of the sphere for simplicity. So the position of each vertex on the surface of the sphere is actually the same as the direction of a normalized normal. The normal of a sphere just goes from the center to the surface. So this is already representing the direction on the normal that is creating a 90-degree angle with the sphere, with the surface, but it actually just arrives since every normal is normalized by default in the GGL grid shape. So it will just cover the it will just arrive at the point in the surface of the sphere, and so be exactly as the vertex coordinate. Actually, the vertex coordinate represents a coordinate, the normal represents a direction in this case, but they, in fact, in the practical, they are actually the same. Okay, so now let's take a look at the last matrix that we get, so the RGB color components. And you know that by default the grid shape is gray, so why are we visualizing this kind of blue here, this kind of purple blue? Well, that's why. Let's create a JIT cell block, sorry. Let's make it plain -1, so we visualize every plane, font size 6, so we can visualize every number. Hop. Zoom a little. And we see that the alpha plane that comes out from the GL object, grid shape, is actually used as the blue plane here. And the red color is used as the alpha, because you know that in Max, everything that comes from GL objects is set as RGB and alpha, and what comes out of matrix objects like the JIT.P window, it's automatically visualized as alpha, red, green, and blue. So this is why we are visualizing the blue component greater, because it's actually the alpha. So if we get just 3 planes actually, then we are visualizing the correct gray, because the alpha component gets counted out. So I think this was everything for this tutorial on how JIT.GEN works. we didn't even create a JIT.GEN object for today, but this introduction was totally necessary to understand further concepts when we are going to work with JIT.GEN. So I hope you found it useful, and if you want, you can support me on Patreon. This would be totally cool. So see you in the next tutorial of this series. Ciao.